Hi everyone. I am Ramesh, Assistant Professor, Department of Mathematics of Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series video, we are going to discuss about the methodology of quantitative techniques. So the systematic methodology developed for an operator research study deals with the problem involving conflicting multiple objectives, policies, and alternatives. The operator research approach to problem solving consists of following important 7 steps. The first step is formulating the problem. To identify the problem correctly, once the problem is correctly identified, 50% of solutions will be arrived. So first understand the problem. From that, if we understand the problem, we get a 50% of solutions. The necessary study comprehensive of the components of the problems are first a decision maker, and second one is the objective, third one is alternative course of action, and fourth one is the environment. These four category are involved when we formulating the problem. So first edition, we are the decision maker. Under what purpose of we are dealing that is the objective. And suppose if it is not happening, then what is the next plan? That is alternative course of actions. Use these three or is making through the environment. So after identifying the components of the problem, the relationship that executes among the components of the problem should be analyzed. Constructing the mathematical model. So model constructions consist of the hypothesizing relationship between variables subject to not subject to control by the decision maker. A mathematical model should include mainly the following three basic set of elements. The first one is a decision variable and parameter, and second is constraints or restrictions and objective functions. So if we convert everything as a mathematical model, then it is easily to solve. Suppose three pens and four pencil rate is 20 rupees. Five pencil and three pen is 12 rupees. So what is the rate of per pen per pencil? So we convert everything as to mathematical model. Then it is easily to calculate. So the generalized mathematical model might take the form is it is f of x comma I, where it represents a system of a mathematical relationship between the measures of the effectiveness of the objective shot z and the variables both controllable and uncontrollable. So next thing obtaining the input data. Once a mathematical model of the problem can be formulated, the next step is to obtain the data to be used in the model as input. Since the quality of data determines the quality of output, the importance of obtaining accurate and complete data cannot be overemphasized. Obtaining correct and relevant data may, however, be a difficult exercise when relatively large problems are involved. A number of sources, such as company reports and documents, interviews with the company personnel, and so they use the collected data. Next, deriving the solutions from the model. There are different kinds of solutions. The first one is a feasible or infeasible, and second is optimum or non-optimum, and third is unique or multiple solutions. A solution that satisfy all the constraints of the problem, uh, including the conditions of the non-negativity, is known as feasible solutions. While the infeasible solutions is one that does not satisfy the conditions of the non-negativity of the variables. Suppose we get some equations x plus y is equal to some 5. If x is equal to 2 and y is equal to 3, both are positive and it satisfies the right hand side value, then it is called feasible solutions. Suppose x is 1, y is minus 3 is a negative, is a non-feasible and does not satisfy the right side also, it is infeasible solutions. Optimum. The optimum solutions to the problem is one of the feasible solutions. Other than the optimum solutions are called non-optimum solutions. We apply the feasible solution to the optimum solution, we get the value. Such a solution is called optimum solutions. In there exists only one optimum solutions to the problem. It is used to be unique optimum solutions. Suppose x plus y is equal to 7, x minus y is equal to some 5. So we get only one solutions for x and only one solutions for y. That is called unique solutions. If an equations have more than two solutions, then it is called multiple solutions is exist. So it is if it is multiple solutions exist, it is too difficult to find what is the exact value. So these are all the different kinds of solutions. Next is a validation of the model. It requires of a determining as if the model can reliable predict or actual systems performance. It also involves testing the structural assumptions of the model to ascertain the validity of a model. It's a compare its performance with the positive data available for the actual system. Controlling and updating a solution which is optimum today may not be in tomorrow. The value of the variable may change, new variable may emerge. The structural relationship between the variables may also change. All these are determinant is updating. The solution goes out of control if the values of one of more controlled variables vary, or a relationship between the variables to indicate the limits within which the model and its solutions can be considered as reliable. This is called controlling. Finally, we get implementations. They implement using the solutions to be achieve the desired goal. So these sevens are methodology of quantitative techniques. Thank you for watching.